Hello, my name is Dr. Emilia Bertolo and I'm a principal lecturer in chemistry at Canterbury Christ Church University in the section of Natural and Applied Sciences. Today we're going to be performing an experiment in which we will measure the acidity of common products that you can find in your kitchen. I've got somebody to help me with me, and his name is Daniel.
Hello.
And before we start with the experiment, I want to talk you through some health and safety issues. First of all, as you can see, Daniel will be wearing safety glasses. Can you put them on? Thank you. Just to make sure that the chemicals we're using do not splash his eyes. He's also wearing an apron to avoid any stains. We are using very small quantities of the chemicals, just again to keep everything safe. And ideally we would be doing this experiment in the kitchen, but our kitchen is not big enough, so that's why we have to do it here. And if you're a child, Daniel has a message for you.
Never do this alone. Always do it in the company of an adult.
And now I'm going to talk you through the chemicals and equipment we are going to be using in this experiment. So these are the chemicals and the equipment we're going to use on this experiment. The first one is bicarbonate of soda. And this is something you can buy in any supermarket and the type of things that you buy to make cakes. This is going to be the chemical that is going to help us check if all the other substances we're going to study are acids. The substances we're going to study are, first of all, water, just normal water from the tap. We also have a little bit of orange juice, so you can see it here. And we also have vinegar. This one is mild vinegar. You can use any vinegar you like. And finally, we also have a little bit of milk. For the last part of the experiment, we are going to use something that is not a liquid, but a solid. It's a chemical called cream of tartar, and again you can buy it in many supermarkets. I'm going to open it here so you can see how it is. I don't know, it's a white powder that you can use for baking. For the reactions, we're going to use these cups, and they're just simple plastic cups. They're all the same size, and this is really important. They are useful because they're transparent, so if you can have your experiment in a glass or a plastic cup, that's easy. You will be able to see the reaction easier. If you don't have several that are the same shape, just use one and keep washing them between one reaction and the next. We have a scoop. This is a coffee scoop. You can use, for example, a you can use, for example, a tablespoon if you want. And this is going to allow us to measure the same amount of all the liquids and pour them in the plastic cups. This one has the same capacity as 2 tablespoons, more or less. And the other thing we're going to need is a small spoon, which is going to the one that we're going to use to measure the bicarbonate of soda. This one is a very small spoon, is more or less equivalent to a quarter of a teaspoon. So if you don't have one of these, just use a teaspoon and try to add only a quarter. It is very important that you use the same quantities for all the experiments, so then everything can be comparable. We also have a little bit of kitchen towel to prevent clean any spills that we might make, hopefully none. And we also have a table to record our results. This is a table that Daniel has done, in which he's put the name of the experiment. He's put all the chemicals he's going to test, and that he's going to test acidity. And he's decided that he's going to use a cross if there's no reaction, 1 tick if he sees a bit of reaction, and 2 ticks if he sees a lot of reaction. And he's called the reaction fizzing, because that is what we're going to be measuring on this experiment.
So Emilia, what do I have to do to make this experiment fair?
Okay, so now you are going to put 1 scoop of each of the liquids in the cup.
Okay.
So one liquid on each cup.
Yes.
And you're going to clean it well
Okay.
from one to the other.
Yes.
And then with a small spoon, you're going to add a small spoon. Try to always add the same amount to the cup, and you're going to see if there's any fizzing. And if there's fizzing, it means that there is a reaction and the liquid you are testing is an acid. Good, so let's make a start.
Okay.
So you're starting with water. You put 1 scoop of the water there. You clean well the spoon so it's ready for the next one. Try to get a spoonful, but make sure that excellent, and you add it. And you can stir a little bit, whirl it, and see if you can see any fizzing, any reaction. No, there's no reaction. So which one are we going to test next?
The orange juice.
So again, you add a scoop of the orange juice. And make sure that you clean the scoop so it's ready for the next experiment. You add a small spoon, yes, trying to make sure that you add the same amount, excellent. And
Yes, there is a bit.
Excellent, and you can hear it fizzling. So the next one, which
The
was the next
vinegar.
one? Vinegar. Again, you try it so you know it's ready for the next experiment. They have already cleaned it. You have it. You can see, yes, there is a lot of fizzing.
And now the last one, the milk.
The last one is the milk. Again, a scoop of milk. You add the bicarbonate of soda.
No.
No, there's no fizzing. So which one do you think are acids?
Vinegar and the orange juice.
They both reacted with the bicarbonate of soda. And do you know what those bubbles were? The ones you could hear?
No.
Do you know what they're made of? They are carbon dioxide, CO2. So the more fizzing, the stronger the acid is. You can try this experiment at home with other liquids. You can try other juices, for example, apple juice or grape juice. You can also try doing it with juices from fruit. If you use fruits, try not to use a juicer, try to juice them manually. And if you use a juicer, strain them through a fine sieve before performing the experiment. And that is because juices can leave a lot of pulp, and then it can be difficult to see the reaction. Another thing that you might want to try is seeing if the bicarbonate of soda reacts with other solids that you have in your kitchen. They won't react in a powder, but if you add water, you might be able to see a reaction. You might be able to see some fizzing. And Daniel, if you are happy, we can try if bicarbonate of soda reacts with cream of tartar.
Okay.
And see if we have a reaction.
Okay.
For this last part of the experiment, you are going to use the bicarbonate of soda that you were using before, and you're also going to be using the cream of tartar. They are both powders. The first thing you're going to do is you're going to put a spoon of the sodium bicarbonate, which is similar to it would be the same as using a quarter of a teaspoon for if you don't have at home one of these smaller spoons, into this container. And we are going to see if they react. So, and clean the spoon before you using it for the cream of tartar. So, a small spoon of bicarbonate of soda, you clean it, and you use it to put a small spoon.
Nothing happened.
Nothing happens. But now, try adding a scoop of water.
It fizzed. Why did that happen?
Bicarbonate of soda can react with cream of tartar. Cream of tartar is also an acid, but they don't react in solid form. You need water for the reaction to happen. And this is what happens with baking powder. That's what happens when cakes grow. Those bubbles that are made of carbon dioxide are formed inside the cake, and that's what makes a cake rise. And that's what baking powder is made of. I hope you have enjoyed the experiments, and thank you for watching. And I hope you have lots of fun making chemistry experiments in your kitchen. And thank you very much to Daniel for helping me today. Thank you, Daniel. So now, if you want to know about the chemical reactions that have happened during these experiments, this is what the second part of this video is about. In this part of the video, I'm going to talk you through some of the reactions that happen in the experiments involving bicarbonate of soda. The chemical name of bicarbonate of soda is sodium hydrogen carbonate, and that's how you will find it if you check in a chemistry book. This is the formula of bicarbonate of soda, and if you see, it has a sodium atom, it has a hydrogen, one carbon atom, and 3 oxygens. Bicarbonate of soda is what we call a weak base, and bases are interesting because they can react with acids. In the case of bicarbonate of soda, when it reacts with an acid, it forms a salt that will include the atom of sodium that bicarbonate of soda has in its structure. It will also make water, and the more important, it will make carbon dioxide. And carbon dioxide is important because it's a gas and it will fizzle out, it will bubble out of the reaction. And that's the bubbles that we observe when bicarbonate of soda reacts. So what happened in the experiments we did before? Well, bicarbonate of soda reacted with vinegar, and the reason it reacted with vinegar is because vinegar contains a compound called acetic acid. And acetic acid is made of hydrogen, carbon atoms, and oxygen atoms. And when bicarbonate of soda reacts with acetic acid, it's capable of breaking this bond here between this oxygen and this hydrogen and forms a salt, it's called sodium acetate, and liberates carbon dioxide, which is the bubbles we observed. What happened with when we do the experiment with orange juice? Well, orange juice reacts with bicarbonate of soda because it contains an acid called citric acid. And in the case of the citric acid, bicarbonate of soda is capable of breaking these 3 bonds. It's what we call a triprotic acid. It means there are 3 bonds between oxygen and hydrogen that can be broken. And again, it liberates carbon dioxide, and it forms a salt called sodium citrate. And finally, we also observe a reaction when we use bicarbonate of soda with cream of tartar. It didn't happen when they were solids, but when in the presence of water, the 2 chemicals could react. This is a structure of cream of tartar.
And as you can see, as in the case of citric acid and acetic acid, it contains hydrogens and oxygens. And in this case, it also contains this atom. It's an atom of potassium. And when it reacts with bicarbonate of soda, the bicarbonate of soda is capable of breaking this bond here and again liberates CO2. And these are some of the reactions we saw in today's video involving bicarbonate of soda. So I hope you have enjoyed the video, and I hope you have lots of fun experimenting with other chemicals, with other compounds, with other products you can find in your kitchen.